13th says 1 plus a square minus b square, then you have a 2ab minus b. You have a 2ab 1 minus a square minus plus b square, 2a 2b minus 2a 1 minus a square minus b square, and then this is another thing that you have over here. What can we do over here? Let's take a look at this. We have 1 plus a square plus b square in the RHS, but then do we observe any such term coming out in the LHS? Common? No, we don't observe any such term. There's a 1 plus a square and a minus b square. There's another thing. Okay, there are no a squares, b squares that can be simplified. There are actually 2ab and 2b. So can we create something called a square and b square in the LHS somehow using some idea? Okay, what I observe is there are two b's over here, there are two a's over here, but there are two b, no, there's no a and b common over here. So probably what I can do is I can take out a b common from here, maybe take out a common from here, and then what do I want to do? I want to do one more thing. What is that? Once I take out a b common, once I take out a common, I want to give them back. But then I don't want to give them back in the same rows, in the same columns. I take out a b common from here and I want to give it back to the first row. How will that impact us? Let's take a look at that. So the LHS, let me write the LHS. Take out a b common from the first column, take out a common from the second column, and you have a ab. What remains is 1 plus a square minus b square. There's no b over here, but you took out a b common, right? That's what would remain. There's a 2a and there's a 2 remaining over here. Since you took out a b common, right? You took out a common from here, so this will be 2b, and okay, there was nothing over here. This is, you took out a common, right? A will come in the denominator, and you took out a common, this is minus 2. What else? You took out b and a common from the first column and the second column, the third column remains as it is. This remains as it is. What else? Now I have a 2, I have a a, I have a b. Let's multiply this b in the first row. Let's multiply this a in the second row. This will become 1 plus a square minus b square. Okay, this will become 2b square. This will become minus 2b square, and yes, this is what you'll have. Then this will become 2a square. This will become 1 minus a square plus b square. This will become 2a square, and this will become 2 minus 2 and 1 minus a square minus b square. Okay. Are we reaching somewhere? Yes, maybe. Let's see. Now, do you observe something called 1 plus a square plus b square forming somewhere? Do you see something of that sort forming somewhere? Yes, maybe. Let's take a look at this one. So, what you have is 2a square plus a square will be 3a square. Actually, you need to add b square somewhere. So, this 2 and minus 2, if you add them together, they will become 0, right? And 2a square minus a square will become a square. 1 plus b square is already there. This 2b square minus b square will become a b square. Yes, you will have 1 plus a square plus b square. Let's add them together. Let's add the first two columns together. What you get is 1 plus a square plus b square. Then you have a 1 plus a square plus b square, and you have a 0. Yes, I have one term of 1 plus a square plus b square over here. Yes. Other than that, let's add these two together. You get a 0 over here. 1 minus a square plus 2a square will be 1 plus a square plus b square. Then minus 2 minus 1 will become minus 1, and you have a minus a square and a minus b square as well. Okay. So what I have done is I have added C3 to C2. What remains is this 2b square, 2a square, and 1 minus a square minus b square. The steps that I have done over here is C1 is replaced by C1 plus C2, and C2 has been replaced by C2 plus C3. That's what you have done over here. Using this will give me, can you take out a 1 plus a square plus b square common from here? Yes. Okay. The determinant that will remain is 1, 1, 0. Okay. You observe 0, 1 plus a square plus b square, and minus of 1 plus a square plus b square. You can take out a 1 plus a square plus b square from here as well. Yes. This will be 0, this will be 1, and this will be minus 1. Okay. The third term will be minus 2b square, 2a square, and 1 minus a square minus b square. This is what you have. Okay. Try to create a 1 plus a square plus b square again somehow. Okay. For that, we'll have to create some zeros somehow, right? Let's try to create some zeros somehow. And what do I observe over here is this minus 1, if it is given to this 1, this will become a 0, right or not? Yes. Or you can add this over here and this will become 0. there's already a 0 over here and I can maybe expand along this column, one of the ways. Or I can create a 0 over here and then I can expand along this one, maybe, yes. Let's try to do that. Let's try to do that. This is 1 plus a square plus b square whole square. Then let's keep the first row as it is. And let's subtract this minus this. What will it become? 0. 1 minus 0 is 1. And 2a square minus 2b square will be 2 times a square plus b square. And this will be 0 minus 1. 1 minus a square minus b square is what we'll get over here. Yes or no? Yes. Now expand along the first column. Expansion along the first column will give me this minus this times this. 1 plus a square plus b square and a whole square times 1 times 1 minus a square minus b square, and minus of minus will become plus 2 times, what will this be equal to? This will be equal to, as you can observe, 2a square minus a square will be a square, 2b square minus b square will be b square, and therefore it will be equal to 1 plus a square plus b square whole power 3. 2 is already there, this will become whole power 3, and yes, that's a complete proof of this one over here. That's the complete solution of this question here.